our speaker, Bob Hendershot, who's going to talk to us about soil health today. Very important topic. Before he begins, let me just tell you some things about him. First of all, he's a graduate of the Ohio State University with a BS in agronomy and soil science.
Go Bucks.
Go Mountaineers.
That's all right.
Anyway, he's a certified forage and grassland professional, and he's a certified crop advisor. Bob retired from NRCS as the state grassland conservationist and state grazing land conservation initiative coordinator. And he informed me that prior to becoming the grassland conservationist that he had been a soil scientist and actually mapped soils, and therefore his interest in primarily soil health. He and his wife live on a farm in Pickaway County, Ohio, near Circleville, where they have a pasture-based sheep operation and occasionally graze some cattle. Bob is a lifetime member and a past president of the Ohio Sheep Improvement Association. He is a sustaining member and past president and former director of the American Forage and Grassland Council. He was the founder and past president of the Ohio Forage and Grassland Council and still serves as a director of this organization. Also, he helped develop the Pasture for Profit Grazing Schools, the Ohio Forage for Horses, and the Equine Environmental and Liability Awareness Program, and continues as an instructor and pasture walk leader. Now, because of his many and varied activities, he's received a number of awards, including in 1996, he received the NRCS Regional Grazing Land Conservation Initiative Support Award. In 1998, he was inducted into the Ohio State Conservationist Hall of Fame. In 1999, he was named the nation's Outstanding Pastureland Conservationist by NRCS. In 2009, he was presented the Ben Stenner Memorial Award by the Innovative Farmers of Ohio in recognition of his excellent contributions to sustainable agriculture. In 2010, he was presented the Ohio Master Shepherd Award by the Ohio Sheep Improvement Association. And recently, he received the Ohio Forage and Grassland Bob Evans Leadership Award for being a champion of foraging. And before he begins, he has placed a handout on the back table back there, and so if you have not already didn't pick one of those up, you might want to get one of those before you leave here today. So at this point, let's welcome Bob for his presentation.
Oh. Well, thank you. That was very, didn't know I'd done all those things.
That's what I did.
We're talking about basic soil health. I'm going to center it more on pastures, but I want you to think about your soils, and are your soils healthy? And how do you measure soil health? And by looking at it, it's the living portion of your soil. The soil's alive. Think about that. It's out there breathing and living. What's your soil tests show about your soil?
Would you be willing to do this? And
you go to the doctor, you get a checkup. That soil test is like your checkup. Give you a lot of results back. And are we really reaching our potential with the soils that we have on our farms? In Ohio, I can say most of our pastures in Ohio do not even reach the potential that they have. We're underutilizing that most precious resource that we have, the soils, in our grazing operations. Because soil organic matter is probably the most important thing we have to deal with. And making sure your soil's healthy is improving the soil organic matter. How did nature do it? How did the good Lord build our soils, especially our grassland soils? Yeah, he used animals. You can't have healthy soils and healthy pastures without having animals and having animal impact. So how do we heal the land? One of those ways is not so much with purchased inputs, but if you think of them, how many of you treat fertilizer as an annual expense? If you fill your Schedule F out, they treat it as an annual expense, doesn't it? Now, I'm not here to rewrite the tax code. But we ought to think about a capital expense. It's like building fence. Soil fertility is a long-term investment. And you need to think about building your soils just like you would putting on building new fence. It's going to be there a long time. Soil fertility should be there a long time. We can improve our soils with additional, but the only known way to heal it, Alan Savory says, is with animal impact. Using the animal. Remember, that's how God did it. He doesn't make too many mistakes. I don't know if any mistakes he's made. But think about it, using those animals. Animal impact is everything the animal does to the soil. Stepping on it, rubbing on it, urinating and dunging, that hoof action, salivating. That saliva dropping out of their mouth has a big impact on what happens in the soil. Shedding. Where's all that cow hair go when they shed here in the next few weeks? It goes back onto the soil. So we think about all those different things we can use. Let's think about, one of the ways we do it is think about stock density. Animal impact is stock density. So I'm going to take you through about 6 or 8 slides here. It talks about how to think about stock density. So if you have 40 head of 1,250-pound cows, okay, that's the only reason I did that, make simple math. Okay, it's Saturday.
Appreciates that as well, I'm sure.
I'm out of school. 50,000 pounds. Of course, I can always tell my stories. What's the average 1,200-pound beef cow weigh now? You laugh. But in Ohio, the average 1,200-pound beef cow now weighs 1,484 pounds. Okay? Farmers still think they have a 1,200 cow. But she actually now weighs 1,484 pounds. Cows keep getting big. Same thing go with the hay bale. The average 1,000-pound hay bale weighs what? It's not 1,000 pounds. It's about 782 pounds. So farmers are great. I'd like the cows and underestimate the size of the bale. And then wonder why their feeding programs don't work out. But think about that. 50,000 pounds, you put them on a 10-acre paddock. What's our stock density for that grazing? Divide the acres in that. It's 5,000 pounds. Okay? Put them on 1 acre, and I can feed 50,000 pounds on 1 acre for a day. Okay? What's my stock density now? 50,000 pounds. Now, how many of you have ever heard of Jim Garish? Most of you probably have. Okay? Jim Garish, as we talked about stock, we really don't think you're doing management-intensive grazing until you got 30,000 pounds of animals on an acre during a grazing event. Otherwise, you're just a real good rotational grazer. You're not getting that animal impact on your land. So you're really not reaping the benefits of a managed grazing system. Now you can go one step first. If we're in a real intensive system, where we're moving the cows several times a day, I put those 40 cows on a quarter of an acre. I can feed them for about 6 hours. But now I have 200,000 pounds of animal. Now we're making change. Do that twice, and you have a different soil now. I'm not saying you have to manage your whole farm like that every single day, but if you did it a couple times during the growing season, when I have a big impact and build new soil. Water cycle. This is a big part, and I put this slide in because most of us went through a drought, and we thought it was broken because we weren't getting any of that. Because the moisture comes up, goes into clouds, it comes down as precipitation, be it snow or rain. Then what happens to it? What happens to it on your farm? Does it soak in? Does it run off? Ideally, we like to have it soaking into our soils because we have use for that of growing grass on most of our farms. If you think about that in terms of organic matter, if you have a 2% organic matter, that will hold 32,000 gallons of water on an acre. Okay? It's a little over an acre inch. 2% organic matter. So what's your soil test say? What's the percent organic matter? One of the sessions yesterday they talked about in West Virginia, you can get that in West Virginia. You have to ask for it. It doesn't come automatically, but ask for it. Those of us in Ohio, we have to pay for our soil test, so we get it automatically. So think about it. An acre inch and 1%. If you have less than that, you can make a big change. In Ohio, my farm, a 10-year storm is 3.7 inches of rain in an hour. If we have any NRCSers from West Virginia, you may know what your 10-year storm is. This is very important to conservationists. We use that as a guide for designing a lot of our conservation practices. But I can hold 31% of that storm if I had 2% organic matter. Okay? If I build my organic matter up to 5, and that's my soils now, when I bought my farm 31 years ago, my wife and I know that date because my baby's 31, okay? We moved to the farm and she was little. It was 2% organic matter. It was broom sedge and Molliflora rose and tall fescue. Now we'll show you a picture of what it looks like. 5%, 5 to 6% organic. I can hold 80,000 gallons. I can hold almost 80% of that 10-year storm. Over 2 inches of it, almost 2 inches of it. So, but if I could get it, my goal is to get to here, 8% organic matter in my pasture fields. 128. I can take all that 10-year storm, plus a little more, and hold it and infiltrate it into my soil. Think about the fact of building organic matter. Every pound of organic matter will hold a gallon of water. Got that? Every pound. Every time we can build our organic matter, we can put more water. What wouldn't be nice last year to have a little extra water? Farming, in this century and beyond, what's it going to take? Managing by disturbing less. Diversity, we're going to talk about each one of these. Feed your soil livestock with living roots. We're going to talk about the livestock you didn't know, you may not know you had. They live underground. I'm here to tell you, I know you have a whole lot more livestock under the surface of the soil than you have on top of it. Okay? And keep it covered. Keep that soil covered up. So let's look about by disturbing less. In terms of physical disturbance and chemical disturbance to our soils. Okay? What's happened? This is the same soil. Mapping soils, I would classify, these would be in the same map unit. Characteristically, they're the same. Physically, they're not, are they? This one on the right-hand side has lost over 60% of its organic matter in 17 years from intensive tillage. This one's in the woodlot. So we have some serious erosion. I know working here in the last few years with some soil science, we're talking about reclassifying some of our severely eroded soils because they're not the same anymore. We've modified them so much in the last lifetime that we've changed the characteristics of those soils. But these two soils developed under the same climate, topography, biota, parent material, and time. But they're totally different now. Okay. Organic matter, soil structure, infiltration, bulk density, water and nutrient holding capacity is completely different from those two now. Now I'm asking you to think about your farm. Go out in the woods and dig a hole, then go across the fence and look at your pasture field and see if there's any major differences in your soil. More than likely they're the same on both sides of the fence. I never once drew a soil line separating pastures on a crop division fence. So soils, good Lord didn't make the soils with fences in mind. So we think about tillage and other things of disturbance. Erosion is still an issue. Erosion is still an issue on our soils because we're also losing organic matter of that. But I found this one interesting. USDA estimates that about half of the fertilizer used every year is lost by erosion. Think about that. Half of the money we spend on fertilizer goes into the streams, or at least off the field we put it on. It's not. Think about tillage. It's not only animal or tractors that cause tillage. We can do it with these guys too. Okay. Any shepherds in the crowd? No, so you left me all alone, my shepherd friends. Okay. No, I said sheep don't do this nearly as bad as cows do. Okay. Another good story is nowhere in the Bible once says anything about cowboys. Shepherds are mentioned over 380 times. Cowboys, 0. Okay? Okay? That land of milk and honey was not cow milk. That was sheep milk. They milk sheep, not cows. Okay? If we think about those nutrients, I put this one because these are the stories our representatives, our senators and congressmen are getting. The bulk of the phosphorus for us in Ohio, we talk about the Mississippi drainage here. No, this is going to Mississippi here, right here. Some of West Virginia goes to the Chesapeake Bay. But it's leaving pasture fields. Nitrogen, on the other hand, over half of it comes from crop fields. That big green spot over there. But our phosphorus issue comes from pasture fields, they're telling us. Okay? Think about that. How is phosphorus leaving your farm? Physical disturbance stimulates first responders. What's God's first responder? If you abuse the soil, what's the first thing that happens? Weeds. Those are God's Band-Aids. You mess it up, he's going to put something out there, and generally it's a weed. Okay? I think that's an intention to get your attention. Okay? God's, hey, you've done something wrong. Look at what I'm going to do for you. Change your ways. Soil destroys, well, tillage or any kind of tillage destroys pores. That cow action, pugging we call it, where they're stomping up the soil, diminishes soil's ability to respire. Remember I told you first up, soils are alive. They're breathing. Roots take their oxygen from where to grow? From the soil. The leaves don't share any oxygen with the roots. Okay? The roots have to breathe the oxygen out of the air in the soil. So we have to think about it. When we disturb the soil, it simplifies the soil fauna over time. Fungi, we lose the fungi portion in the soil. And we're going to show you some pictures of how important the fungus in the soil is to the plant growth. Because it's these mycorrhizae fungi that help the plant take up phosphorus, zinc, copper, and iron. How many of you use zinc, copper, and iron for your livestock? I bet it's in every bag of mineral you buy. Is it because you don't have active fungi in your soil that are helping those plants take those minerals up? Because what's the biggest mineral in your soil? Iron. It's iron. Why are we buying it in a bag? Diversity is critical. Okay, you're thinking about it. We talk about diversity, I'm talking about diversity of plants. Fescue and bluegrass are not diverse. They're both cool season grasses. Orchard grass and tall fescue are both cool season grasses. That's not diversity. Diversity is warm season and cool seasons, annuals and perennials. Foxtail is a warm season annual grass. Then you got your broadleaves. Legumes are broadleaves. And there's cool and warm season broadleaves. Dandelions, a nice cool season broadleaf. Why is those important? Because they all have different rooting depths and how they grow. Think about that dandelion, sending down that deep taproot. Chicory, forage chicory. On my farm, I always put forage chicory in my frost seedings. Chicory is a deep-rooted, we call it a perennial, but it's like red clover, it doesn't last as long. But think about it, all these different plants are rooting at different depths, different kinds of root system. Some of them have fragmented or branched. Don't want to poke anybody in the eye. this. Or you have thick grasses that have a thick mass of roots. They're all doing something different. The grasses are very important in terms of growing soil organic matter. Our grasses that we grow lose half of their roots every year. They die and are regenerated. It's the only plant that can regenerate new roots. Think about what happens to an alfalfa plant if the root's damaged. Dies. What happens to a tree if you prune the roots of a tree? Dies. When you're, well, I was going to say granddad, but when my granddad, probably be your fathers for you guys. When they cultivated their corn, what were they doing? Pruning roots. That's how you controlled weeds. The weeds were pruning the roots. But grasses, our perennial grasses, can regenerate new roots. What happens to the old roots? They stay. Food for the bugs. That's right. You're feeding the soil. Because they need those. And that's how we get organic matter deep into the soils. How was those nice, dark, black prairie soils developed? 14 feet of nice, dark topsoil. Grasses. Those roots were down there deep. They died, decayed, rotted away. The grasses grew new roots, and that process over generations. We can do the same thing on our pasture fields if we manage our roots with good diversity. Why is it important? Some of you may not have soils that go 48 inches or 7 to 8 inches deep, but a lot of our minerals are deeper in the soil, especially calcium. Okay. If we have a dandelion that goes down here, capturing in it, pulling that calcium back up, where's it going to be? Now we've pulled it to the surface. Your animals, I know my ewes love dandelions in the spring of the year. They eat that because it is high in calcium. My ewes are lactating. One of the things they love, are craving, is calcium. Okay? So we get that now back on the surface. They eat it, what happens to it? Some of it goes to milk. Take you through the long stage. The lamb drinks the milk. What's the lamb do with it then? It may use some of it to grow bones, but a lot of it gets passed back out. That lamb's pooping and urinating too, along with the ewe. So we get it back on the surface to utilize it again. So we think about the roots. Understand the longer we rest our grasses, the better. If we overgraze, what happens to our root mass? Remember, when do the grasses grow most of their roots? In the fall of the year. So if you overgraze in July, you don't have, this is what your plant looks like in August and September till we start growing new roots again. Because what feeds this? Where do the roots get their energy from? The leaves. Roots can't make energy. They can supply the minerals and the water up to the tops, but the leaves in return share their energy back down and grow the roots. Understand that. Feed your livestock in the soil like you do the livestock on top. Have you ever thought about feeding the bugs in your soil like you feed the bugs in the rumen of your cows? Okay. My friends, animal nutritionist friends, thought I didn't know anything about animals, but I knew a lot about soils. You realize the soil is a whole lot like a cow's rumen. That all depends on microbiology. Think about it. What's the source of all energy? Sun. God made light in the way of the sun. Energy comes down, that green plant can absorb, because we can't get any energy out of the sun. We can get kinetic, warms us up, but doesn't feed us, does it? But that green plant can take that light in the presence of chlorophyll, make sugars, which then are extruded out, feeds the small plant or small soil life, bigger soil life, worms, and then the bigger stuff. And then we can also harvest this with our animals that can utilize that and make it work. So the soil food web is important. Those things depend on diversity too. Just like your cows depend on diversity. A variety of things and diversity in their pasture in terms of what they graze, also does the animals in the soil like a diversity. So if you look at it, the number, I don't know if you need this number up top here. You know what that? 800 quintillion. So I could be a budget officer for the U.S. government now. So I could say that big number, okay? Think about that. A healthy soil has that many bacteria. Antibacteria, a little less. But look at the pounds. Over a ton of those. The fungi, you should have over a ton of fungi in your soil, okay? Then there's algae. You realize there's also blue-green algae that can take nitrogen just like the rhizobia does in your legumes in your soil. Do you have them in your soil? Have you ever analyzed it? And not all nematodes are bad. 99% of the nematodes are good guys. But if you're a soybean producer in Ohio, every nematode's a bad nematode. Okay? We have cyst nematode in soybeans. Earthworms. There's 16 different species of earthworms. Do you have earthworms in your soils? When I do a pasture walk, I'm known for taking a shovel with me. And one of the things I do is pop up a shovelful of soil and look at it, and there ought to be a worm in every spadeful. A worm in every spadeful. Then you know, because you can't see these guys up here. Most you can't see nematodes. Well, I can see these. You can see those. And that, if I have these, then I know I got these. And I don't have to look at it. Do I know I have enough? I don't know. We have to look at our plants to see. Also understand that the energy is supplied by those plants down to the feed those critters, just like the ones on top. So when we're grazing here, we're also feeding the animals underneath. Because this is what a root looks like. If you would blow it up and look at it in electron, this stuff out here, that light colored, are excutilates. The roots are oozing out energy, sugars. Okay? That's feeding the bacteria and the fungi. This is went too far. Let me go back. Spoiled it already. These are root hair. These are not root. These are fungi living on this root. This is a root hair, and these are the little fungi attached to it. They're living off the energy of that, the bacteria as well, and they're moving nutrients into the root, and that's how it works. This one, and you always thought roots were slick and smooth. That's what a root looks like if you would blow it up. It's a rough, hobby-looking thing, okay? It's not a smooth, shiny surface. And then here's a particle of soil.
Like everybody, we try to graze clear up it, right? I mean, I've got
The sugars
some fescue
out of that plant, okay? If you have that grazing animal out here, that grazing animal stimulates that plant to exude those things out there because it wants to keep growing. So it feeds the soil microbes, which in turn feed the plant to keep it going. If the animals weren't there, that plant would never excrete any sugar back out in the soil. So your populations go down. Think about a cornfield or a hayfield that doesn't have any animals in it. They don't have near the microbiology populations that a pasture does because they don't have that impact with the animal. Okay. Granddad never wanted the cows in the corn, did he? Because he didn't think about this. So it's a way of balancing that, making that work. So this is those fungi on there. Look at it. If you could blow them up, we blew that picture up even more. Not we, somebody did. Look at all those.
the way that was.
That's what makes a healthy plant. They're attached to the root. If your plants get overgrazed, what does the plant do? It's not enough energy, so these guys starve off, sheds these off. Just like a legume plant does with the rhizobia bacteria. You cut or graze a legume plant too short, and when we cut it for hay, we cut it too short. You take all the leaves. There's no energy there. What's the plant? The first thing it does is shed all those things off. Because, hey, I don't have enough energy for you and me both. So you got to leave. And then it starts growing, and it can repopulate.
Quit maybe doing that.
There's a spore bank or a residual bank of bacteria and fungi. So they interact. They assist with phosphorus uptake. They moves the phosphorus from the grass to the legume, and in return they lose the nitrogen from the legume plant back to the grass plant. So there's stuff going on all the time. So this afternoon I'm going to talk at the very end of this about how important it is to have legumes in your pasture field. If you just have straight grass, this is broken. We need to have that diversity of plants in our soils. So let's look. We'll take a trip now. How are we doing with time? Good? Because we're going to take this fantastic voyage. Whoop, yeah, there we go. We're burying into the soil. Now we're in here. Don't get sick before lunch here. This is where you're at. Think about what's going on down in here. All the things that are happening. There's a lot going on in your soil. I love this. Ever had a chance to go to the Smithsonian and see the National Soil Exhibit? They call it the Secrets of the Soil. It's a wonderful, every soil scientist should have seen that. There are more living creatures in a shovelful of rich soil than human beings on the planet. Yet we know more about the dark side of the moon than we know about the soil. You heard Bill this morning. He talked about the lack of understanding of the the rumen microbes. The same holds true here. We don't understand what's going on in our soils. Just like we don't understand everything that goes on in that cow's rumen. Tremendous amount of knowledge yet to be understood. Keep the soil covered. As a conservationist now, this is important. Some of you may have seen this demonstration out in the field. Some of you may say none of these are overgrazed. This is a short canopy. Look at the soil erosion we got. Even a medium canopy where we maintain it at 3 to 4 inches. Our runoff at this point, when we have a tall canopy, it's really clean. We're getting some water movement down through the soil profile because these traits are percolated, so we're catching both what runs off the surface and what percolates down through about 3 inches of soil there. So we're getting some movement, but you can see how much percolates. And that's what you want. You want that water in the soil, not running off. And it all triggers on how much canopy we have. And this happened a lot last year, where we grazed too short, took off a lot of canopy. Look at the soil temperature. Thermometer here is 91.2. Over here, just a few feet away, 77 degrees. Which is healthier for the soil? Cooler the better. What kind of grasses are you growing? Cool season grasses. It's no longer cool when it's over 80 degrees, okay? Think about that. Because when we get to 100 degrees, 85% of the moisture in your soil is lost through evaporation or transpiration. Only 15% is going to be used for growth. You get over 130 degrees, then everything's lost. And there were days last year when our bare soil temperature was over 160 degrees. We were killing bacteria, sterilizing it on some of our fields. So think about keeping good cover. There's multiple reasons why we need to not overgraze. This is just one of them in terms of soil. My goal on my farm is to be sustainable through soil health, keeping that soil active and alive. Look at all the worms and the worm holes. There's a little worm there. There's another tail. There's a little guy there. Understand how healthy. They increase the productivity of your farm because they're ingesting, they're taking soil in there, and the stuff coming out the back is a whole lot better than the stuff coming in. They make phosphorus more available. They make the whole system work. How long does it take to build soil organic matter? I talked about how my farm has improved. So if we're growing 3 tons of forage in a pasture field, and we use the old rule of take half, leave half, that means you're leaving 3,000 pounds back. Cows are excreting some of that too. But the root mass is going to be more if we're doing a good job. And half of that falls
Keeping them that extra.
6,000 pounds of root,
ones I've seen.
6,000 pounds of plant material on the surface. So we've added 9,000 pounds of gross organic matter. It's not soil organic matter, it's just biomass, okay, into the soil. That'll be converted in there. You realize you have to have 6,000 pounds just to stay even. Just to stay even. The soil mineralizes about that much every year. So you've got to replenish 6,000 pounds every year. That's the reason in our grazing schools we talk about your pastures should be getting better and better every year, because you should be returning more than 6,000 plants. If your pastures are not, I'm guessing you're not returning enough organic matter back to the soil. And you're going backwards. You're losing soil organic matter. You should be building soil organic matter. So we'll talk about Tim Kelly. You may not want to hear about me. He took, these are his fields, he's standing up. These were once corn soybean fields. They were highly erodible, for those of you in our CSers that know what HEL land is. This is HEL land. He converted them all to grass. Diversity of grass. Okay. He started with, a lot of them were in the 3.6 to 3.9, and in 10 years, he raised them from 3.9 to 6.9, 6.2, 6%, 5.2. In 10 years, I was impressed he could get that. But he had started with good fields. Remember, he started with corn soybean fields. I started with a multiflora rose, broom sedge, and tall fescue. Could be the difference. The average forage production on his farm was 8,000 pounds. That's 4 tons of yield per year. Do you even know how many pounds of forage you're growing on an acre on your farm? Have you ever measured it? Every corn producer in Ohio knows how many bushels per acre they harvested. But as grazers, do we know how many we have? He one year grew almost 9 tons, 18,000 pounds. Okay. My farm, I've been measuring now for 12 years. My best year was 15,910. Over 7.5 tons.
Probably don't have a cat.
Of pasture. Not in corn silage, that's pasture.
Them
Year before that was 14, over 7 tons, 14,316. I measure my pasture growth every week during the growing season. So I know exactly how much I'm growing out there. I use that a lot in terms of managing what's going on. If you want to read a book and learn some of these things, these are some good books. We'll take you back. But Teaming with Microbes is a real good one. The Soil Primer, or Soil Biology Primer, is another one. The Managing Cover Crops, so it talks about cover crops. It talks a lot about soil quality and soil health in that as well. And let me finish up here. The quality of our life depends on, actually, it's the food we eat, the water we drink, and the air we breathe. But all those come from the quality of the soil that we have. Every glass of water you drink has been in contact with the soil. We purify it. The air that we breathe is recycled through the plants that grow in the soil. The food that we eat all comes from the soil. You can't think of a food that we eat that doesn't come from the soil. Even the fish in the sea get their nutrients from the soil. that have eroded off the soil, gone out to the ocean, supplied the food chain out there. So everything we eat comes from our soil. Think about it. How much respect do we give it? Oh. Is that the last? No. We've got time. I'll go back to this one so you can, if you want to keep those. The soil is the basis of everything. I believe the soil is the most important thing we have to take care of. God given us the charge of being stewards of His creation. The soil is one of those. However, we have to consider the whole when making these decisions. You got to look at your animals, because they're going to generate the income to help you maybe regenerate your soils. I understand that we need to look at our animals. You got to look at your financial goals. Because remember that I talked about fertilizer being a capital investment, not an annual cost. And there's that's a different philosophy how to think about making some of these purchases. You probably can't go to the bank and borrow money to buy fertilizer as a capital investment. He doesn't think of it that way. Because he wants that payment back quicker than that. He probably won't give you a mortgage to buy fertilizer. Okay? He should. He probably won't. Personal goals. Set some goals for yourselves of improving your farm's soil health. Increasing the organic matter, improving its fertility. It may not be the whole farm. Take a field. I always encourage people to look at their best field and get up to the very best. If you can take your best field and get it the most productive, then it'll generate optimal performance. And we generate some financial goals for you to generate dollars to start improving the rest of the farm. So my philosophy is not treat the worst first, but get the best better. Maybe it's my old FFA. Make the best better. Or is that 4-H? 4-H. I should have looked at the extension guy. Make the best better. Think of it in terms of doing that way. Oh, we got time? Got some fancy slides for you to look at. Oh, wonderful. If you got questions. This is my new experiment I'm going to be working on. This grazing corn, utilizing corn, because it's a high value, but look at how much we're leaving on the surface. We're putting radishes in there. One of the things I talked with somebody yesterday about, I've always grown oats and turnips as a shepherd, as a winter feed option. What I did this year, I took from what I've learned in my working with my crop folks of some of the complicated cover crops, diversity. And I had a 5- and 6-way mix that I planted. Not only oats and turnips, but I also added a forage pea, triticale, annual ryegrass, and a crimson clover. So now I got this complexity with the whole idea I'm going to build more diversity and a better soil health. And it's also providing feed. I'm putting this right in to my tall fescue pasture fields. They're mostly tall fescue. But we use the netting, knock a row down. But notice what they did first. Ate all the brassicas. They're still trying to figure out how to eat this. They eat the leaves off. As a boy, I grew up on a diversified farm. We milked cows, had beef cows, had sheep. And we picked all the ear corn. You know how old I am now. But we used to turn the sheep in the fall of the year into our cornfields. And they would do exactly this. Clean all the leaves off the bottom. They would eat any of the nubbins. It's the way we flushed our ewe flock. Okay. Now they weren't the 300-pound Suffolks. Okay. So we had 150-pound Cordale ewes. But we'd turn them out there, and it made picking corn a whole lot easier. Grandpa was a whole lot pleasant to be around if they didn't have all those leaves and extra fodder down there when we went out to pick them.
Oh, he told you he did it, but tell him again.
The same when we're growing it for this. My new change this year is using male sterile corn. Won't have an ear on it. All we'll have is leaves. We'll plant it a little thicker, get a smaller stem that we can utilize. This is a concern. They're going out.
Look at what cow-cows,
If you think about density, I got this slide from,
we also keep,
he talks about
And we-
stock density and the impact it has on a farm. If you've never trailed
have really cheap,
cows,
you might buy.
there he is up there. Okay. I think it's 250 head in there. And he's moving them from one pasture to the next, going down the, actually this is a township road in Missouri. Here they're coming in, or in or out of the field. They're moving. This is what's behind them. They're all following one another. Think about that as you look at it. Questions? This is unique for me. I finished on time. So it doesn't happen often. Andy said, I know. He's heard me talk before.
Since you brought it up, what techniques are you using to measure your growth?
Measuring my question was, how am I measuring my pasture growth? I use a rising plate meter, okay? And have you ever seen a rising plate meter?
There might be one in this state.
No, okay. Well, we have a special project in Ohio. We got 36 farmers that are measuring pasture growth, and we're collecting that. Some of you may know Jeff McCutcheon, from the McCutcheon clan of West Virginia. But he coordinates that. I helped him get that started. What we do, it's a metal plate, and they come from New Zealand, and the grass holds the plate up, and it has a counter on it, and it measures then the height of the grass, if you will. Also has a hand counter on top, a clicker like a bale counter, and you count the number of measurements you make, record your beginning number and your ending number, subtract the ending from the beginning from the ending, divide by the number of observations you have, and then you have a average plant height, if you will, and density. On my farm, the hardest part is calibrating that plate meter. Okay? On my farm, it's 106 pounds of dry matter per acre per click, if you will, on that, or mark on the plate meter. The number I get from my plate meter, I multiply by 106. Okay? The summertime, it's a different number than it is in the spring and the fall because of moisture content. So I use a different number depending on the time of the year. So the grass crunches when I walk across it. It's different than when my boots are wet when I walk across it. But that's what the tool we use. Pasture sticks work well. That's a $500 tool. Okay. Pasture sticks that some of you were carrying around can do the same thing. You just have to take more up. You got to take the same 30 observations, but you got to remember all the numbers. Because as you walk across your field, it may not always be the same density across the field, or you got to find a spot that's very, very representative of what you have. So that's the reason it's just like taking a soil test. You walk across the field and get about 20 to 30 different observations. We like 30. Takes the variability out. McCutcheon's the statistician. He comes up with all those numbers and makes sure it's the standard deviation and all those things are covered in the research part of it. Steve?
Could you talk about the comparison between mob grazing techniques and management-intensive grazing in relation to building soil?
Well, that's kind of what the slides were, some of those were about. That's the difference between that half a million pounds and 50,000 pounds. 50,000 pounds is management-intensive grazing. 5,000 pounds is rotational grazing. That 500,000 pounds is mob grazing.
But doesn't mob grazing detail the growth of the age of the forage?
Yes, well, to some degree. It allows for complete rest. So the plants have fully usually come back. In a mob grazing technique, you're only grazing once or twice a year. Usually 2 times out of 3 years, or 3 times in 2 years. You're grazing any one spot. Now, think about this. Okay. In management-intensive grazing, we're more of keeping that plant in a vegetative mode, but still not grazing it and letting it get too tall. So we're still allowing that plant to fully rest and regenerate itself, but the plant never matures, if you will. Mob grazing, you're letting that plant mature and fully express itself. Which is better for the soil?
Which one would build organic matter quicker?
Quickest, the mob grazing causes the stocking density. Okay? Now most of us, when you think about mob grazing, most of us don't mob graze because we can't tend the animals that much. If you're mob grazing, you got to move them at least twice a day. Okay? Even if you have full rank field, you got to be moving them at least morning and night. Or most of us work off the farm, so it's not that easy. I can do the same thing on a less height, if you will, management intensive grazing style, but I got to move them 5 and 6 times a day because I don't have physically as much material out there. So I got to keep them moving, if you will. I had dairy farmers when I first started over in Zanesville. He moved his fence 12 times a day. Okay? Which for him, you may think, oh my, I ain't no way I would do. But he used to feed hay 12 times a day when he was a conventional dairyman. Hay and silage. So to him, it wasn't any different. I'm still feeding my cows the same, only instead of putting it in a bunk, now he's out moving instead of starting a tractor, he's just moving a polywire. So it's a little different. So we can still do mob grazing with shorter grass, but we just have to move more often. In terms of building the soil, they're probably equally the same. Now, in the mob grazing ones, you get more lignin, so it's a slower process, but it's probably more, I won't say sustainable, but you get a bigger impact because you're adding physically more material to the soil at any one time. So it's kind of like the race, the tortoise and the hare. You may still end up at the same place at the end. It's how fast you want to get there. Does that answer? Okay, that's a thought-provoking question. Yes, in the back?
I understand that you talked about cover and the importance of litter with your babies. You still have to make some hay to get through the winter. Do you have any recommendations there?
My goal is not to make any hay. That's what we'll talk about this afternoon, the 3 o'clock session. My goal, Bob Evans' goal, is cows should never have a bite of grain or a bite of hay. Now, that's a big goal. For some of us, it's not achievable. But my goal is to get down as close as I can to that. Okay? Making hay sometimes isn't. My question to you, can you afford to make hay? And I work with a lot of beef cow producers that have more invested in their hay equipment than they do in their cows. Look at your inventory, put a value to it, and is your equipment worth more than the cows you're feeding the hay to? You realize most of the beef producers I work with, that's a true statement.
If we do hit the cows,
May have 150,000 haymaking equipment to feed 20 cows. And I know those cows aren't worth $6,000 each. Okay? So those are questions you all have to answer in terms of me. I don't make my own hay anymore. I still use between 300 and 700 bales of hay a year, small square bales. Okay? But I can buy the hay cheaper than I can make it for my animals. Now you say, well, what do you do with that spring flush or growth? I feed my microbes now. I don't wait and clip my pastures in July. I have them all clipped before the 1st of June. Because just like cows don't like patriotic hay, and patriotic hay is the hay that's made the first time on July 4th. Okay? That's not high quality feed. For your cow, it's not high quality feed to be clipping my pasture and feeding the livestock I have in my soil. So I want to feed them the same quality, the livestock, the bacteria and the fungi in the soil, that I would feed my animals. And it's easier to feed them because I can clip it in May and not have to worry about rain. And keep those plants vegetatively growing. And and not have to worry about it. And I realize that's a big hurdle for a lot of you to get over of making hay or not. First hurdle, do I have hay fields or do I have pasture fields? That's a hurdle. I've worked with a lot of producers, and I have no problems, I can work with them, that have a hay field that no animal ever sets foot in there. Okay? And I said, well, I can talk to them a long time about why. So I think you should graze everything every year. You should have a fence about everything that's grazable, not the woodlands. Take grass fields, why aren't we grazing everything? Utilizing those animals more than we do. They say, well, compaction. They're pulling a 150 horse tractor with a hay baler that's weighing 5 tons through a field, and they're worried about a 1,484 pound cow. Which causing more compaction, the tractor or the cow? The tractor, friends. The tractor is the biggest compactor you have on your farm. Not the cows. Cows only compact about 6 inches deep at the most, even in the muddiest conditions. That 150 horse tractor is compressing down about 12 to 18 inches on the weight of the tractor. So think about what we can do and how we can utilize our, and those are hurdles, paradigms. They talk about jumping out of the box, or the paradigm box. Each one of you have your box that you live in that you've never stepped out of, and some of those things is changing those things, changing what you have. If you keep doing what you've always done, you always get what you always got. Got that one? If you never change, you can't expect change. And the biggest hurdle we have for most of our farms is changing what we've always done. If you want something different, then you're going to have to do something different. So we'll talk about how we can stockpile grass at 3 o'clock in terms of growing more feed. And like most of you, I have a tall fescue farm. If you have tall fescue, you ought to really think about being a wintertime grazer. If you're going to feed hay, you ought to be feeding hay in July and August and September, not in December, January, February, and March. Think about that. That's a big paradigm jump. Question?
Well, I've seen a product advertised about, not the appliance, spray or granular, but bacterial, your soil is supposed to go for like beneficial. Are you aware of it?
Oh. I don't know exactly which one you're talking about. I'm learning more and more soil biology and the products and inoculating our soil with the proper biology. A lot of our soils have lost some of that biology, and there's probably what's done with soil biology in terms of selecting higher quality bacteria, just like Mr. Tucker talked about improving the genetics of your beef cows. There's also been improvement done with the genetics of bacteria, and there are a lot more. Some of the big ones are changes in rhizobia. Jim Berline at Ohio State has dedicated his life now of selecting new lines, genetic lines of rhizobia bacteria are twice as efficient, will generate more nitrogen than the old lines of bacteria.
Other answer.
So there's a lot of things we need to know about the soil biology, and I think we can probably improve, because it takes time, and one of the things we need to do is inoculate our soils with some of these bacteria. Remember those numbers? 800 quintillion? I didn't separate them out by species. That's just bacteria. That's like cows. There's a lot of different kinds of cows. There's a lot of different kinds of bacteria as well. So some of the stuff is good. You just got to look and see which will do. Universities have not tested the biologicals that much that I'm aware of. So a lot of it has to be done on farm. But I've worked with organic corn farmers that are growing 250 bushel corn organically with utilizing biological type fertilizers and microbes. So there's stuff out there. Remember I talked about that nitrogen moving back and forth and the phosphorus moving back? All done by microbes. Do you have them in your soil? I don't know. I couldn't know like looking at it. If we put them out there, then I know we have a population. But it takes time to build that population. And then you got to feed them. Corn, soybean plants, how many days out of the year are they alive? Yeah. Think of, when you buy seed corn, you buy it by the days that it's alive. 105 to, there's shorter terms and longer terms. That's how many days that plant's alive. How many days out of the year is your pasture field alive? 365. We have a great place to utilize more of the biology than the corn farmer does, because we can feed that plant more often. Corn farmers are starting to say that with the use of cover crops now, where they're keeping more plant cover out there, growing plant cover, feeding those microbes. And they're seeing yield boosts from that. It's more than just nitrogen and phosphorus. It's more just than chemical. And I understand it. I grew up in the university system where chemical fertilizer was all we were taught. But there's a whole lot of things. It's that dark side of the moon slide that we don't understand, don't know.
I don't know how you'd ever put figures to that. I think that's, every situation's gonna be different. How big a pipes you got going to your truck? Water is, how,
Lunchtime for us,
for your spring,
I want to present Bob with a small gift here, the token of our